We can use state machines to create efficient code as compared to sequential code, where we can transition from one state to any number of states depending on the transition code. In this video, we will be creating a simulation for the game rock, paper, scissors. Since ours is a state machine, we will have states and transitions between these states. Transitions are shown by arrows, and the boxes show the states. So we'll start with the initialized state. Then we'll proceed to the wait for input state. From there, we will check if the start button is clicked. If it is clicked, then we will go to timing state. Then from there, we wait if the hand is shown or the timing is false. Then we will go back to timing. If it is not, then we'll show the hand and it will be completed turn. Then we'll go back to wait for input, and then we wait for start button. If it is start button is not pressed, then we will see if the reset button is pressed. If it is pressed, then we will go back to the wait for input and go through all the states. If the reset is not pressed, then we will see if the close panel has been called, which is called when the upper right side cross button is pressed. If it is not, we will go back, wait for input in all the states. If it is pressed, then we will end this state machine. So let's start by creating a new project. Let's create a blank project. Click finish. Let's save this project. In a new folder. Let's call it state machine. Let's call the project state machine as well. Let's create a new VI. Let's save it as well. Let's call it state machine as well. Let's create its front panel first. Let's place a boolean button. Let's call it rock. Let's put the same string as a boolean text. Let's create a new button. Let's call it paper. Let's create another one. Let's call it scissors. Let's copy this text. Set it as boolean text. Let's create another one. Let's call it start. one, let's call it reset. Text, paste it, and let's have a string indicator. Let's call it computer and another one, let's call it status. So now we are done with the front panel. Let's replace this string indicator with an enum, which will be more appropriate for us. And this status as well. So let's now convert this into a type def. Open type def. Let's edit items. First item would be rock, then paper, then scissors, and the next one would be blank. Let's save it. Yes, computer hand. Let's close it. And let's create status. Same thing. Change make type def, and then open type def. Edit items. First item would be use. Second item would be win. Next item would be type. Next item would be click start to play. Next item would be 1, 2, and go. Let's save it as well. Let's call it status. Let's close it. Let's go to the block diagram and create a state for our state enum. Let's change it to a type def. Make type def. Open type def. Let's edit the items. And our states would be initialize, wait for input, timing, computer's turn, shutdown. Okay, let's save it as states. So now let's go and create our state machine. First we will need a while loop, in which our states will be handled. Then we will need a case structure for handling individual states. Then we will connect our case structure with this enum, states enum. Let's connect it. Let's add case for every value. Then let's add a wait of 100 milliseconds. Let's bring our status enum over here, and our computer hand over here. Let's add a shift register for booleans. Use later, and let's convert this into a shift register. Our next, from initialize state, we will be going to our next state, which is wait for input. Our constant would be click start to play. Another constant. Let's set it to this one. Let's set it to blank. Let's initialize our, let's create a local for rock, for paper, and for scissors. Let's initialize them to false, all of them. and let's create and also let's use same constant for additional terminal so that we do not stop our loop here. Further, let's create some error in and error out. And let's connect these. Let's create a shift register for these. Connect these to these shift registers for monitoring errors in our code. Let's pass these through. And we are done with this state. So let's go and create our next state, which will be wait for input. We will be using an event structure to monitor the pressing of the front panel Boolean buttons. The first one will be start button, add event case, start value change. So in this state, let's bring the start here, and in this state, from here we will be going, if the start button is pressed, then we will be going to the timing state. The status would be click start to play, and computer hand would be blank, and we will be using a VI, an action engine, which we have to add, which we had already created in a previous video to our project. Add a file. Let's go to action engine. We will be using this action engine in our project. So let's drag it here. Let's call it with start timer. We're initializing our timer, and we will not be false constant, and we will not be stopping this loop in this event. Let's pass this wire through, and we are done with this event case. Now let's create an event for reset button. If the user presses the reset button, let's bring it inside, and if this is pressed, then the next state would be wait for input. And the status would be click start to play. Since this is a reset button, we will be initializing everything to their initial state. So we'll copy these locals which we had already created and place it here as well. So our last event would be panel close. Go to event case, SBI, and panel close. But the filter event. In this, we will be discarding it. Create constant, set it to true, and the same. Set it to false, and pass this the true constant. Since we want the loop to stop if the panel has been closed by the user. So let's go now to the next state, which is timing. In this state, we will be using these buttons and using them to decide our next state. Let's build an array. Of these three elements. Let's pass a copy of it to this shift register we had already created. Let's or the array elements. This function. Then we will be ORing it, or if any of this button is pressed, select either of the two states. If the buttons are pressed, then we will go to computer's turn state. If that is not the case, then the other alternate for us would be to go to the timing, which is the same case. We will keep visiting this state. Next, we will use our timer VI. See if check timer. We'll see if the 3 seconds has elapsed. If that is the case, then we will also be going to the computer's turn. Let's place a base structure. Let's round this this value, time elapsed, and let's convert it to unsigned 16. And this is what the case structure input expects. The case is 0, then we will go to the status would be click start to play, and the computer hand would be blank. The error wire would be passed through, and we will not be closing this loop in this case. Use default if unwired. In the next case, which is 1, we will be showing him 1. Let's add another case. If it is 2, then we will be showing the text 2, and if it is 3, then we will be showing the text go. And let's set this as the default case as well. So next we move to computer's turn case. Since the logic for computer turn was a bit complicated, I have gone ahead and created the logic. So here we check the timer and see if the 2.5 seconds have elapsed. If they have elapsed, if it is true, we check which of the 3 buttons have been pressed by the user, and we generate a random number, and according to that, this is the choice that the computer has made, and according to that we make our different choices about user winning and what the computer has selected. If time has not elapsed, then we go and declare the user as a loser. He has lost and time has elapsed and he has not made a choice, and so we display these user computer hands. Since we had decided to use the shutdown state, but we are not going to use it, let's delete this case. And since we are using the locals, we cannot use them with the mechanical action for latching. Let's change their mechanical action to, let's say, switch when released. And our VI is runnable.